I'm here with Stephen Bowyer. Stephen, welcome. You are the department manager at Mobility Technologies for a lot of different technologies, from calibration, certification, development, vehicle development. Tell me a little bit about it.
Correct. Yeah, so our group more or less handles everything in the physical world, whether that's engine development, could be e-motor development, battery development, calibration of engine, traditional powertrains, transmissions, electrification, hybrids, BEVs, even ADAS or assisted driving features. We do certification with the regulatory bodies and the testing that's required for that. We can lead that as well. And then we also have our vehicle team, which looks at ride, drivability from a benchmarking perspective, but we also do vehicle builds, which are in many cases pulling out the traditional powertrain and converting it to a battery electric vehicle, or converting it over to a fuel cell electric vehicle.
Okay. So very diverse, but essentially you're driving the world here. It's not the software guy that always claim they do. Sorry, software guys. It's you. You have the physical stuff, right? The stuff that moves.
That's correct, yeah. Yes. Ultimately, all of that has to come into the physical world to move physical things, right? Yeah. And so what's interesting about the group is we have to know a lot about the mechanical side of the vehicle or engine or powertrain. But in addition, we also have to know a fair amount about the software, right? Because specifically with the calibration piece, you have to understand how the software is controlling the physical world.
So how close then is your relationship with our software group under Fessel, who was here previously as well? Is this like a daily interaction? Is this they give me requirements or we give them requirements and we deal that way? How important is it that we're in the same building, that we're in the same company, that this capability is within the same four walls, quote unquote?
Yeah, it really depends on the type of program that we're working on. So in some cases we have projects where we're writing the software that's going into a vehicle conversion, and we're calibrating that as well. And so in those cases, we're on a daily basis, complete integration of the teams, and there's a lot of interaction. There are some other projects where our customers are providing the software or the controller, and we're doing the calibration piece, let's say, but all of the software is provided by the customer. So we really have a lot of flexibility. Sometimes it's our software group that we're working with directly. Sometimes it's our customer software group. It really just kind of depends.
Okay. So I think one area that I feel like maybe many people don't think about it being relevant in the future, certification. I think many people probably know certification is very critical today for ICE or diesel engines, so gasoline or diesel engines, from an emissions point of view, et cetera. But what about from an EV? I mean, is this like certification is not important anymore going forward? The regulatory body says, hey, it's an EV, you're super clean, don't worry about it. Where do you see this?
Yeah, there's certainly still certification that has to be done. And we have helped several of our customers with those certification requirements, but it is simplified in comparison to a conventional powertrain. With that, I guess we can't assume that the traditional powertrains are going away, because they'll be here for quite a long time, and we have. In 2025, we have the SULEV 30 calibrations or certifications levels, rather. They have to be calibrated, and we have to meet those requirements. And of course, I imagine that those will get even more strict as we go forward. And so even though BEVs are the hot topic, and they certainly have, we have a lot of work to do for developing those vehicles. Those still have to be certified, but we also have our traditional powertrains, which also have to be certified and actually have to get better over time. And so it's quite an interesting time right now because we have really two paths, and both of them are advancing state of the art as we move forward and transition from predominantly one or entirely one, let's say, to more prominence in the electrified space.
So you've been in the industry for a long time. I've worked for many years in ICE development, internal combustion engine development. So going back to the certification, maybe even calibration related thing, but certainly certification, Europe now is starting to come out and will have regulations in place that looks at the entire life cycle of an EV, or of an EV battery at least, right? How from a greenhouse gas or emissions point of view was this battery developed with all its components? How was it charged? With what energy was used to create the cells to charge it? Where is the vehicle going to be used? So how is that power that is necessary to constantly charge it affecting the overall carbon neutrality or carbon footprint? And then also looks into or provides regulations that relates to recycling. That's in Europe. You've been in ICE engines where a lot of things came out of Europe and maybe made it over here or was adapted, or new things came here and went to Europe and was adopted there, and maybe China or Asia as well. What do you see with batteries?
Yeah,
or with EVs in general, I guess. It doesn't have to be batteries, but with EV vehicles, right?
I think it's the logical next step that has to be looked at. I think one of the more recent studies that I've seen is that a typical battery electric vehicle, when you buy it, is 3 years behind the conventional powertrain in terms of CO2 production, because it does create so much CO2 in the supply chain to get the EV just built. And then beyond that, right, we go into where are you generating the electricity? What's that made from? Obviously a very significant amount of electricity is still made from coal in the United States. And then on top of that, there's natural gas, and of course, wind and solar are very small at the moment contributors. So, this push to go from a conventional fossil fuel based powertrain over to an electric powertrain really doesn't make any sense currently, right? But it's setting the stage that it only makes sense if you look at the upstream effects of creating a battery electric vehicle, and then also the downstream effects of, you need to have it powered by either wind, solar, or nuclear. Otherwise, there's really no CO2 benefit. So it wouldn't surprise me if they move that way.
You're saying the U.S. would adopt a certain regulatory type thing as it relates to EVs similar to Europe? I
think that's the only way that it makes sense.
Yeah, okay. Calibration, again, for me, I've worked with internal combustion engines for many, many years as well, and always was clear, you got to calibrate it, you got to put it all together in the complete system with your transmission and all that. So again, overall, just vehicle calibration. When it comes to an EV, is there still calibration as well? Because I think in some cases people think, oh no, you got an e-motor, off you go, it runs, right? Well, what's the big deal, right? Everything else is just software. It's just...
Yeah, certainly there are fewer variables, and that helps simplify the calibrations. But the behavior of the battery and the electric motor are different when they're cold versus hot. You have different settings for regenerative braking. You have different safety concerns, and all of these things need to be considered.
So with internal combustion engines, the calibration is heavily focused, or was heavily focused, on emissions-related topics and drivability as well. Is it then for EVs going forward, as you said before, it's simpler, it's not as complex, it's still complex, but all relatively speaking, simpler than ICE calibration. But is the BEV then more focused on drivability, the ride comfort, and those things that are much more affecting each individual customer versus the traditional calibration, which again, with a heavy focus on emissions, greenhouse gas, and those things?
Yeah, certainly it's a little bit probably less focused on noise and vibration and harshness, but certainly there's a drivability aspect to it. NVH is still an issue. In some ways, it becomes more difficult because you don't have the sound of the engine to kind of, if you will, mask or cover some of the other noises that you have in the vehicle. But, along with EVs, we're also advancing the ADAS. And so then that becomes a much more complicated calibration as well. And of course, you have different sensors and things that, we need to tie into the network, and they all have their limitations, and making sure that we keep the occupants and so on safe.
When you're talking about future vehicles, your team does a lot of prototype vehicles for customers where new technology is integrated into what you mentioned earlier, an existing vehicle, oftentimes maybe propulsion related, but could be all sorts of other components as well. What is the one thing that you feel oftentimes customers forget about when they do, or when they want to do a prototype vehicle? Is it a challenge of the communications network? Is it a challenge of trying to squeeze some component into an existing vehicle and having to make all sorts of new mounting and structural changes? Is it the expectancy that when this vehicle is done, it's going to drive like it's a production vehicle and has gone through the design, validation, and testing over a year and a half or 2.5 years, even though we've only worked on it for 8 months? What is it in your experience that customers sometimes forget on the challenges that we're faced with developing that technology or prototype vehicle?
Yeah, so that's a very good question. A lot of times we'll find that the customers know the big things that have to change, right? There's a cross member on the frame that has to be removed and has to be replaced with something. Probably the largest thing that we see is just not an appreciation for the complexity of even a BEV or a fuel cell vehicle. And when I say that, you think, okay, the battery has to go here. I have to remove this mounting frame piece, or I have to make this cut and weld of some other components. That's identified up front. What may be not identified is there are still cooling circuits that still have to be handled. There are large diameter wires which don't bend very easily that have to be accommodated. And so just all of these little integration things, and then you have to have mounting supports for all of these parts, right? And so then there's a significant amount of effort to take a vehicle that's designed for an engine, transmission, drive shaft, and a differential, right? To take all that out and put a really big e-motor in the back, maybe one in the front, and a big battery in a spot that was not intended for a battery. So I think that level of complexity isn't always seen up front. They see it after the vehicle's built or partially built, about the complexity that we have to deal with. The fuel cell electric vehicles are even, a step further, because there is a lot of complexity with mounting the hydrogen fuel cells, and then routing those at a very high pressure to the fuel cell, and then the cooling systems and on those as well. So I would say all of that leads to a compression in timing that sometimes becomes very difficult to achieve.
Okay. When I look at different technologies and how they have progressed over the years, what is the most difficult part of developing a vehicle or designing a vehicle, prototype or for production, that you now more than ever rely on simulation technologies?
Yeah, so largely for the programs that we work on, the simulation, if we're doing a conversion for a BEV or a fuel cell, is making sure that we size heat exchangers right, we have the right flow through the cooling lines, and make sure we keep the batteries cool. Of course, those are critical. The other piece to that is that these battery electric vehicles are significantly heavier than a traditional powertrain. So then we have to do some work with suspension systems, and sometimes it's relatively straightforward and simple if it's a very easy demonstrator. On the other hand, if the customers are looking to maintain the same ride and drive qualities, then we have to do more work on that, and simulation tools certainly help us out.
Okay. Calibration. Tell me a little bit about calibration and use of simulation tools. We hear the term virtual calibration quite often. We have some tools that we use for virtual calibration. Mm-hmm. How widely deployed are those tools? And how much does that give you? Does it give you 10% and then 90% you still a person has to do? Or can it get you to 90%, or is it somewhere in between?
Yeah, so most of the calibration that we do for our development vehicles, we don't leverage that so much. A lot of our advanced calibration stuff is really more around the traditional or conventional powertrains.
Uh-huh. So for those programs there, where we're asked by an OEM, hey, help me with the calibration, with your expertise, with your tools, how much can we leverage there, our virtual environment?
Absolutely. Those virtual tools can be used to cover a significant portion of the operating map. Uh-huh. And of course, then we still need to go in and make refinements to a lot of our calibrations, based on drivability and emissions testing and so on. But it does simplify and reduce the amount of time that we need to spend in a test cell. And of course, test cells are very expensive, and so.
Good. Steve, when it comes to calibration, I oftentimes hear virtual calibration. And I know it's not going to be whatever 90% can be done in the virtual world. Press a button, it flashes that calibration file, and then you do a few tweakings and off you go. But if you use some of our tools that we have that are specifically suited for virtual calibration, for a traditional ice engine, for example, how much do you think can be done in the virtual space before then engineering capabilities and other tools will take over again? Is it 10%? Is it 90%? Is it somewhere in between? What's your guess here?
Yeah, so it's a very difficult question to answer because of the wide range of complexities, between diesel powertrains and gasoline and automatic transmissions versus AMTs and those types of things. But generally, I think maybe 30-40% could be done upfront with the virtual test bed, and then that gives us a basis. And of course, that's a pretty significant savings with full emissions test cell based work.
Sure.
And so.
And you see that 30 to 40% starting to creep into 50 and above as technology and models and fidelity and all that stuff increases, or do you see there is a certain limitation at some point?
There is absolutely a limitation that because we're using a combustion model to support that and it's not a live combustion, and there are things that happen in the physical world that and phenomena that we have to that we discover, have to learn, and have to manage, right? So it'll never get to 100%, but it certainly can reduce the cost of the full development effort.
Okay. Last question, Steve. If you had 3 items that you see in the technologies that you're responsible for at Mobility Technologies Inc. at AVL here, what would they be? What are the three big technology changes that you see happening in the next 5 years, let's say? Technologies you're responsible for.
Yeah. I would say that trying to think, outside of the normal answer of, battery electric vehicles are going to.
Yeah, that's sort of the standard. I mean, you can go down, right? There's more simulation,
Yep.
There's more virtual calibration, as we just talked about.
Yeah.
It's interesting sometimes to see the different perspectives. You're in the middle of this stuff, right? You have your hands in daily meetings and daily with your team on different things. What do you see we're going to be at in 5 years that you say, wow, this is really one of my top 3 cool things that are changing slowly but surely, right?
Yeah. I would say that calibration for conventional powertrains and hybrid electrics will continue to be big, probably longer than most expect. Even once we do come out with a significant number of BEV offerings, and that increases every year, we have to get market acceptance for that. In the meantime, we have to continue to produce vehicles that are meet requirements for emissions and keep the automakers in business. And with that, most of the automakers are working feverishly on the electrification side, and to some extent, the conventional powertrains are a distraction, if you will. And so, we can help alleviate that load. We have with our skilled calibrators. So I think that's one piece. The other piece, I think, is ADAS will continue to grow and become more sophisticated. And we can help out on that as well. We've conducted major programs in the U.S. as well as, of course, in Europe. And we leverage that learning worldwide. So the ADAS calibration and the software development is going to continue to grow. And then I think the third one is, I think will become big. There's not a lot of talk about it at the moment, but I think as we start to see some of the conventional powertrains be extended into the future, I think there will be some focus on how to make those cheaper as we move forward, so that at least when they do sell them, that they become more profitable with those. And there's a lot of, in order to change hardware to new manufacturing processes, let's say, or redesign to have fewer components, a lot of that has to be tested and developed and make sure that you don't have an adverse effect on durability. So I think those areas I think are going to be big in our group.
I would say, especially on your last point, right? I mean, IC engine development is going on for over 100 years. And I mean, when I sometimes look at the cost for an engine, I'm blown away how inexpensive it is, relatively speaking, to the complexity of it. So now, and you're saying is that you think there can be even more cost being taken out with given its due time, that you say right now is a little bit pushed to the side, but may come back again in the near future as that becomes necessary. So that's an interesting point.
Yeah.
Okay. Thanks. Thanks, Steve, for your time. Thanks for tuning in.
Thanks for listening to Reimagine Mobility Podcast. If you like this episode, please subscribe and tell a friend.